Light-dependent resistor.
Okay, now have a look at this question. Okay, so when you're going to do questions with light-dependent resistors, they must provide you the property of the light LDR. Okay, normally it's in a graph like this. Okay, so as you can see, the x-axis tells us the light intensity, and the y-axis tells me the resistance of the resistor. So in this question, when the light intensity is 10 lux, the resistance is 6. Always remember, be careful with the unit. It's kilo ohms. Okay, so it's going to be 6,000 ohms. So once you read, just be careful with the unit. So once you read the resistance of the resistor off the graph, okay, then you can do your normal calculations. So LDRs, the light-dependent resistors, they are just variable resistance. Okay? You can just treat it as a variable resistor. So, but the photodiodes are a little bit different. Okay? Just remember now, when the light shines on LDR, if we look at the previous page, okay, when light shines on LDR, the resistance of the device changes. Okay, so that's the property of LDR. And what's happened is with photodiodes, when the light shines on the photodiodes, okay, the current the current passing through it changes. Okay, so yeah, it's basically well, yes. So for photodiodes, it's basically controlled. Okay, it's basically controlled in controls the current. So when there's more light, when the light intensity increases, okay, the current travels through the diode increases regardless the resistance. Okay, regardless the resistance, regardless what's happened in the circuit elsewhere. Okay, so that's the beauty of the photodiodes. It relays light intensity and the current in the circuits. That's why this is an effective optical detector, okay, because it modifies the current straight away, so we don't have to no. Yep. So yep, have a look. Yep, this is this little symbol down there, down below, is a symbol of photodiodes, and the property of the photodiodes are given in a graph, something like this. Okay. As you can see, as as the light intensity increases, okay, the current, okay, the value of the current increases. They're all in the negative direction because that's how they design the photodiodes. Okay. So, because if you have a look, because the light intensity and if you look at this graph, the current, they're all below the x-axis. They are in the negative direction. And that's why when we use the photodiodes, especially light intensity, and the light intensity cannot be negative. The minimum is 0 and it cannot be negative. The reason it happens is due to the design of the photodiodes. So somehow they design the photodiodes like this, so when we use it, we have to use it reverse biased. Remember for a diode, say if I have a say if I have a power source here, I have a circuit, okay, and the current flow from positive to negative. Okay. Normally, for diode, we should put it in the forward direction. Okay. So the current be able to flow through the diode. Okay. Only with photodiodes, we cannot do that. For photodiodes, what we have to do is we have to put it in the reverse biased direction. In the other word, we have to reverse it in order for it to work. Okay, we have to put the photodiodes in this direction, so the current is able to travel through the diode. If you put it in the normal direction, the circuit doesn't work. Okay, the current will be blocked by the photodiode. So just remember, when we use a photodiode, the diode must be in reverse biased direction. Okay. And yep, yep. Now let's have a look at some questions. Okay. Okay, for a particular photodiode, it has a current of this, and the voltage of this, and the light intensity of this. So if the light intensity is unchanged, okay, somehow the light intensity is unchanged, and somehow the voltage drop is doubled, then what happens? Okay, I will give you a few seconds and have a look. Choose your answer there. Okay. Now, the idea is, okay, remember the unique property of the photodiodes. Okay, the photodiodes only, well, the change of light intensity only influences the current. Okay. It's also the same way around. Okay. If the current is in a photodiode is only related to the light intensity. Okay. Say if the light intensity is unchanged, no matter what happens, no matter what else happens, the current will be unchanged. Okay. The current remains constant. So the answer is C. Okay. That's the unique property of the photodiode. C. Okay. Then have a look at the next question. Now, we talked about this kind of question before. Okay. The examiner is asking me, by the way, those are the exam style questions. The examiner asked me to describe the purpose of a photodiode. What does it do? What does a photodiode do? Just remember the photodiodes converts. Okay, it's a detector, so it converts light energy into electrical energy. And that's your answer. Okay. Now look at the next one. Okay, here is a little bit complex one. Now we have a graph of the photodiode. Okay. The vertical axis is the current, the horizontal axis is the light intensity. Okay, and yeah, the circuit should really look like this. We have a positive battery in this end, which is 5 volt, and we have the ground, which is 0 volt on the other side. So the current is able to travel from the positive to negative when the photodiode is reverse biased, like when it's pointing in the opposite direction. So the diagram making sense. And the question asks me, if there's no light, shines on the photodiode, uh, what's the output voltage of the resistor here? Okay. Then we go through our uh, diagram. When the light intensity is 0, the current of the whole circuit, since this is a series circuit, the current doesn't split up. The current should be 5 mu amps. Okay. 5 times 10 power of 6, minus 6 amps. And then when we have the current, we can easily find out the voltage, V equals to IR. So 100 times 5 times 10 power minus 6 amps. Sorry. Okay. Put it in your calculator, it's going to be 5 times 10 power of minus 4 volts. So when there is no light shines on it. Okay. Now the important lesson is, when you see a photodiode in the circuit, just remember the value of the current depends on the photodiode, regardless what's happened elsewhere. Okay, you need to find the current through the circuit first. Okay. Now let's look at